Okay. Here we are, guys. Welcome to the Salty Dogs webinar on Thursday night with Hank George, and tonight we're talking about lithium-ion batteries. I'm just making sure I have everything turned on here. Okay. Mute all, and then I'm going to unmute. Mute all. Sorry, guys, this is my first time doing this. Hank, can you hear me?
I can hear you just fine.
Okay, good. Well, welcome everyone. This is George Day with Salty Dog Sailing Association. I'm happy to greet you guys this evening and to welcome Hank George to come and talk to us about lithium-ion batteries for our cruising boats and for other purposes as well. We have worked together. Hank and I have worked together for a long time at the Salty Dogs, and it's interesting to see how he's migrated his interest forward from his engineering days. Hank's an engineer, and he was the second president of the board of directors for the Salty Dogs, and did a great job bringing us forward into a new era. And he now has launched with his wife Seal this nice company promoting and promoting and selling lithium-ion batteries for cruising boats and for RVs and for other purposes as well. So I'm happy to welcome Hank, and I hope you guys really enjoy listening to his presentation on lithium-ion, which have changed the cruising world, in my opinion, in a dramatic way. So Hank, I'll turn it over to you.
Well, George, thank you very much, and good evening all. Appreciate you guys joining us this evening. One of the things we'll ask is that you hold questions until the end. I think we're going to be opening a chat, George.
Yes, and, well, the chat is open, so just post your questions. Yep.
Yeah, so you can post your questions there, and we'll try to get to everyone at the end. So thank you again. And so George touched a bit on my background, and I don't want to dwell on that, but let you know that lithium batteries were something that I got involved in 14 years ago. I put them on our boat and several other boats, doing a lot of that work down in the Caribbean. So that was sort of my first introduction. Stayed in touch with a number of key companies that were leading edge at that time, and they have continued to be that way. And so we're fortunately able to continue our relationship with them, and we're doing that through Blue Heron Battery. So going to run through a lot of information tonight, and if you end up with questions afterwards, certainly use the contact information that will be provided at the end of the presentation. Welcome any further questions or comments. So what we'd like to do, let's see, so that's not working. Let's try this again. Well, my screen has frozen here, George. There we go. Okay. So, a question that a lot of folks ask themselves would be, why lithium? You're hearing a lot about it in the news and media from friends. So there's several significant benefits that lithium brings to deep storage battery applications. You end up with twice to 3 times the usable capacity as compared to an AGM, which was, we had considered 10 years ago, 12 years ago, leading edge. Well, this has twice the usable capacity in the same size battery, 10 to 20 times the available cycles, so that they last very, very long, typically a 10 to 14-year life. They are half the charging time. They accept charge much faster than lead acid batteries. They're about half the weight, even a little bit more. Makes a big difference on something like a lightweight cruising catamaran, which we did. We put them on our Katana 471 14 years ago. And so, it realized amazing benefits, all through the period that we owned that boat. Lifetime costs, once you go through several cycles of replacing AGM batteries, you'll find that the lifetime cost is about the third with lithium over that period. And of course, there are, a higher upfront cost, but not that much more than AGM now. Costs really have come down. And there's zero maintenance, and there are other benefits with, intangibles in terms of resale value for a boat, being able to sell the boat when it has lithium, a well thought out system. So what we're going to talk about tonight, what I'd like to cover are some of the elements of a lithium upgrade. I've got the little circle here with 8 different segments representing some of the major steps that you have to go through. There's some front end determinations you need to make on, which manufacturer do you want to buy from, what type, the form or shape of the batteries they're going to work best for you, and who is going to do the installation. So a good bit of upfront work. And then shortly after that is then figuring out the sizing. What size do you need? And we're going to talk about that tonight. Third is location. Where do I put it? Do I put it in the battery box where my other batteries were, or is there a better location, or do I need a bigger footprint? Alternator, how do we address that? Chargers, battery chargers, solar chargers, wind controllers. What do we need to do with respect to them in terms of them mating up with lithium? What do I do about start batteries, bow thruster batteries, windlass batteries? If I do a house bank in lithium, what about all those other applications? The BMS, or battery management system, what that is and why it's there, its purpose, etc. And then some best operating practices with your lithium battery bank. So we'll touch on all those things tonight, and let's jump right into that. So selecting the manufacturer, chemistry, the form or shape, and the installer. So one of the key questions up front is, do I, focus on US, or, do I consider import batteries? And I think the big advantage with staying with a US company is access to tech support and confidence in the warranty. There are a lot of little companies out there offering lithium batteries. And in reality, a lot of those are used batteries, ones that are maybe reject batteries from manufacturer. And the best way to work your way around that is to deal with a reputable company. So they've done the homework to figure out, what is good, what are good cells, and such. Chemistry, there are various options. I'm going to touch on this a little broader later, but there are a lot of different chemistries involving lithium. And, some are good, some not so good. And so we'll touch on that a little bit. But the bottom line is, stick with lithium iron phosphate. You'll find some batteries out there that are lithium cobalt, lithium manganese. They have their applications, but you don't want that for your house battery bank. There are different types or form made with prismatic cells, cylindrical or pouch. And the pouch cells have a good use in our phones, cell phones, and our computers using lithium iron phosphate or maybe lithium cobalt. And so they're very high energy density and they work well for that. But the pouches are soft-sided. They don't hold the cathode and anode plates in place well. And so because of that, they have a shorter life. And that's why our cells don't last quite as long in our cell phones or in our computers. But prismatic will be a longer life. Cylindrical are cheaper to manufacture. They can be mass produced. And they work a little better for rapid discharge. If someone's building a lithium start battery, that's really the cell you want to use. For deep cycle, prismatic is hands down the best. 90% of the batteries going into electric vehicles these days, even a little more than that, are all prismatic cells. They're excellent for deep cycle performance and long lasting. So other issues, do I get a drop-in battery versus modular? It'll depend a lot on the configuration of your battery bank, but also what your needs are. So there's some decisions to be made there. Do I want an integrated BMS versus an external? Pros and cons with those. I guess just generally be aware of what I call the internet bazaar. You can go onto Amazon and other places on the internet and find really cheap lithium batteries. And the fact of the matter is, lithium is an expensive product. If it's a new battery, it's not going to be $200 for 100 amp hours. That's a used battery. or it was a reject because it doesn't put out the capacity it should. And so just be careful with those. Then you have to make a decision on installation. Do you do it yourself, boat yard or mobile installer? I think, I'd caution people to try to be careful, cautious about trying to do it yourself. There are a lot of things that can be done right, but can be done wrong when you do it yourself and you're not used to doing it. We had a friend that had done it himself, and then he hired an ABYC inspector, and the inspector looked at things, started pulling some cables, and they were moving around on the terminals. They weren't tight enough. He'd pull on them and they'd pull right out of the crimp fittings. So these are things you think look easy, but you really need to be experienced to do that right and to do it well. So big caution there. So battery bank sizing, you have several options on ways you can look at this. With your existing battery bank, it gives you a great reference on usable amp hours. So you look at, your battery bank, let's say it's like the little picture I have to the right, if you can see it, at least on mine, I've got my pictures of everybody blocking that. But, if your battery bank AGM were, for example, three 210 amp hour AGMs, then that's 630 amp hours total. 315, 50% would be usable amp hours. And that's just the nature of lead acid batteries. You got to be careful not to keep cycling it below 50% capacity, or right from the start, you can be taking away significant life. And so you'd have a 315 amp hour usable. Well, how did that work for you in cruising? Is that substantially undersized to what you need? Did it work well? I found that on Katana, they put such a large battery bank in AGMs to begin with. It was a 960 amp hour battery bank. It had worked very well for us cruising. And so 50% of that would be 450 amp hours. So we put in a 600 amp hour. We used that as a frame of reference, but bumped it a little bit. And that size just worked great for us cruising. So another option could be, instead of just trying to get the same usable amp hours, maybe with a little bit more, you could say, I'm just going to put batteries in the same space where I have them now. And what you'll generally get is about twice the usable amp hours that you had with your original battery bank, just the way it works with the sizing of lithium batteries. A third can be someone who says, well, I'm going to be operating a business off the boat. I want to have a lot of capacity. I'm going to be operating Starlink. We're going to be doing convection cooktops and big energy users like that. So I want to just pile in all I can fit in the space available, maybe the battery compartment and maybe an adjacent compartment. So that can be the third way you look at it, just pack in the power. So you just need to decide what's right for you, but you can use that existing battery bank as a very good frame of reference and go from there. We have some general guidelines that we've passed on to folks. Small sailor power, you can see it here, under 34 feet. Typically about 200 amp hours is, works fine for those. Mid-size sail, that may be 36 to 45 feet. 300 to 600 amp hours, and larger boats, say 47 to 60 feet, 600 to 1200. We've supplied batteries that go all the way up to 3000 amp hours in a 70-foot boat. So, people choosing to do a lot more than what was there originally. In that case, that more than doubled the capacity that was originally in that 70-foot, the usable amp hours in that 70-footer. Okay, moving on to one of the other decisions you need to decide, and it may be your installer that helps you with this, where should you locate the batteries? Generally, you'll find staying close to the original battery bank minimizes the impact, but it may not be as much space as you want, and so you may decide to go under an aft bunk or something like that. And so it can go in a locker, it can go under the cabin sole. Can go in an engine room. You want to be careful about the heat in the engine room. And a lot of people get concerned about, we don't want to get any heat going into these batteries. And so, some relative temperatures to be thinking about. Most engine rooms are going to be peaking out, at somewhere around 110 Fahrenheit. The lithium batteries don't get into a thermal runaway until you're up to 238 to 250 degrees Fahrenheit. So, it's kind of a big difference. You can put them in an engine room, ones that have a large engine, so a lot of airflow because of the combustion air that's drawn out of the space, can help keep that down. but our advice is generally try to find other places and do that as sort of a last resort, but make sure you've got excellent ventilation so that it doesn't peak any more than about that 110 that I mentioned. You get in a hot car in a day, just by comparison, that may be 120 degrees to 130 degrees. So, you want to keep it below those kind of temperatures. And so, for example, you don't want to leave them sitting in a hot car, although they're sitting and they're not being used, so you're not adding heat from charging or discharging. So another key aspect with the lithium batteries is securing them. You see several pictures here that have some clamping plates over the top, threaded rod to an anchor. With lithium, you want to be holding that battery firmly in place. ABYC standards for AGM, lead acid, allow the battery to slide a nominal amount, like an inch, but no more than that. But that creates some impact loading if you were to do that with lithium, and so you want to avoid that. The plates in a lithium battery are very, very thin, paper thin, and built up with separators between them. They're suspended from the top and the bottom of the cell case, but you just don't want a lot of that lateral type of loading by having it slide around. So you generally do some blocking or chocks at the base so that they're held fairly securely. Then you clamp it down, and they're not going to go anywhere. So other things to consider are the various charging devices. Alternator tends to be a challenging one, but it's very solvable. There are options. One is you can have it, just leave it feeding the house bank, and just leave it that way. If it's a very small capacity, maybe you're not going to try to draw any power from it. Or if it is of any size you want to draw power from, then you can add a DC to DC charger so that you can harvest some of that charge over to the house bank from your engine running. You can upsize your alternator, add an external regulator, and there's even a step where you can take a large one that has an internal regulator, take it to an alternator shop, and they can modify it to accept external regulation. I wouldn't generally do that for your stock regulators. They're just not worth it. There's not that much energy coming out of them. But I would do that if you had, say, a stock one that was a 150 amp or 200 amp or larger. Then it would be worth taking it to a shop, have it modified for external regulation, put, Balmar, for example, external regulator on it. And have that feed directly to your lithium house bank. It can be a large source of power for you, and so it's one to pay attention to. But when you do that, there are a couple of other factors you need to consider. One is to protect against a load dump to where the alternator had nowhere to send its power. The best solution to that is a fairly new device, came out last year, that Balmar has, and let's see, who is it? Well, and there's another company that has a competitor device, but it's an alternator protection module, an APM. It's either the APM 12 or the APM 24. You want to put that on every alternator that's feeding your lithium bank. And the other thing you need to do is add a temperature sensor, an alternator temperature sensor that feeds back to the external regulator. And in that setup of the external regulator, the third component you have to be very careful of is to depower the alternator. The alternator, 150 amp alternator, will all of a sudden be putting out 170 amps because lithium has virtually no resistance. And so it overworks itself and overheats. And so Balmar recommends just starting at a 30% power reduction, and then use a temperature monitor, or a little, handgun probe, infrared sensor, to see what temperature you're getting up to with the regulator at a low RPM, or on the alternator at a low RPM, like 1300 RPM. And so if you're staying below 90 degrees Celsius, then you've got things set up well. If it's cooler than that, then you may be able to bump it back up a little bit, another 5%, and then give it a try. But don't push it. You can burn up an alternator that way. But with the temperature sensor and with that initial tuning at installation, alternator will do fine feeding into a lithium house bank. So a third option is something called a battery isolation manager. And there is an image of that in the lower right of my screen, if you can see that. And that's another option that's used on used a lot on trawlers, but use the existing alternator the way it is, and it just links the two together. If there's charge available at the start end, it then charges for 20 seconds, turns off for 10 seconds, sending charge from the alternator over to the house bank. And it then has settings in it, so it knows the maximum battery voltage that lithium wants, and so it'll stop that process once the house bank is charged. And so it's a very simple device, works well, and you don't have to do any programming like you'd have to with a DC to DC charger. Very energy efficient, and it works the other way. If it senses that the house bank is getting charged and the start battery could use some charge, it then will flow some of that direction to, you know, maintain the start battery. So interesting little device. So charger settings, you want to adjust those to fit what the lithium manufacturer calls for. And virtually all chargers that are built in the last 10 years have some ability to adjust them now. Prior to that, it was hit or miss or very little opportunity to change. And so you may not see a lithium setting, and sometimes that's even preferable. It may not be set to the right voltage that the manufacturer wants. Some of the early lithium settings, people were thinking, well, let's just go to 14.6 or something like that. And research has now showed that you really want to charge less than that, more like a 14.2 for the longevity of a lithium battery. And so, you know, you need to adjust those settings. Solar controllers, similarly, you know, Victron and many of the others all have an ability to adjust the, you know, infinite settings so that you can get to the lithium settings that the manufacturer wants. You know, back to chargers, by the way, I would say that, you know, what we have found is that this is such a key component. You want it to be very reliable, not only to be able to charge, but you don't want it to go wacky and start overcharging. And we have found some, you know, knockoff, you know, non-US, non-European made chargers that are causing people some problems. And their BMS keeps tripping off. And once they put the voltage monitor on it, they find that even though they set it for a 14.2 setting, it's charging at 15. So I would really highly recommend, if you're replacing any equipment, stay with Victron, Mastervolt, Magnum, and Xantrex, you know, really sound, you know, sound equipment. Solar controllers would, you know, like I said, need to be set, but wind generators, you're going to have a harder time. There are very few of those that have sufficient adjustment. So you may have to replace the regulator with one that does have lithium or adjustable 3-stage charging capability. But the other is, if you're keeping a battery for something like bow thruster, keeping a battery that's AGM or large, you know, large enough on a start battery as well, AGM, you can just send the wind generator charge to that AGM battery and then use a DC to DC charger to harvest back to the house battery bank. And then you don't have to change any equipment or settings with the wind generator. Just let it keep doing what it's doing right now, but just not directly to the house bank. So what about these, some of these other functions, a start battery, the windlass battery, bow thruster batteries? Yeah, all of those, if you have separate batteries for those, obviously you would for start, you know, you can keep them as AGM. You don't have to be switching all of those to lithium. Some boats use just the house bank for the windlass and the bow thruster. And so in that case, you'll have to pay attention to lithium BMS current capacity, the peak amps that it's able to handle in the BMS to make sure it can handle the windlass and bow thruster batteries. You have to look into the specs, owner's manual on that equipment, and you know, see what those peak current needs are. Often the better solution for that is, rather than going with say one big lithium battery or two big lithium batteries, maybe what you do is go with 5 smaller ones and you end up with higher amperage capability that way. So something to pay attention to there. But AGM works well because it really is ideal as a rapid discharge, which is what you need for a start battery. It doesn't do quite as well for deep cycle, and that's why you're only using 50% of it. You know, you get into issues of sulfation, and so they need a higher voltage to try to drive a lot of those components that, you know, the sulfates and others back into solution. But what you can do is keep them separate. You know, if you're able to keep, you know, if you have, say, bow thruster batteries that are separate and a start battery, obviously it's AGM, you can keep them as AGM and then just charge them with a DC to DC charger from the house battery bank, sending most of your big charging from alternator or battery charger to the house bank, and then DC to DC charger to keep those others topped up. You can also use an isolator. It does work fine. I mean, we use that on flash for a lot of years, and you know, the start batteries would last 7 years. So it was, I mean, there was no significant issue for them being charged at the same charge profile as lithium. There is a bit of a detail if you do deep discharge and you happen to use your bow thruster a lot, so that you are deep discharging it, then it probably is better to have a, you know, a separate charge capability for it that will get it up to its 14.8 voltage that it needs. And so a DC to DC charger could do that. It could take what the house battery has and it can bump that up to give the thruster that higher voltage that it needs. But if your thruster is not used that way, you may find the isolator is the quicker, easier, less expensive solution. So the BMS, it's abbreviation or acronym for Battery Management System. And the battery management system, some people see that name and then they infer what they think that must mean. Like it must control all the charging that's going to batteries. It acts as sort of your new charge regulator. Well, a BMS does not do that. You need to look at it as a backup safety device. It's monitoring various parameters, you know, voltage, amps. It does its own little computation of state of charge. And you know, it looks at if you are approaching some critical set point on, say, a low voltage on a cell or low voltage on the battery itself, or if there's an excessive discharge, a short circuit somewhere. The BMS will actually operate faster than any of your fuses. And it'll terminate discharge from the battery if there was a short circuit somewhere. It operates in milliseconds. But it's monitoring voltage, monitoring amps, monitoring temperature. And if you approach some limit there, it then may terminate charging. Maybe you've got a runaway charger, like the example I gave you earlier, where someone was throwing 15 volts at their lithium batteries, and the BMS said, whoops, nope, we're going to stop charging. The better BMSs will have separate control over charging and discharge. So if it stops charging, you still have power from the batteries on the discharge. And so, you know, it's a feature you want to make sure your BMS has when you're looking at different batteries. A Bluetooth option is very powerful. We do that on all of our deep cycle batteries. And a number of other manufacturers do as well, but some don't. It is costly. It adds expense to, you know, to the basic BMS and to the overall battery, but it allows you to have some monitoring capability of what's going on in addition to your regular battery monitor system, which is a segue into sort of this best practices. You want to have an ability to monitor at a glance, not through Bluetooth. Bluetooth, consider that as a backup because it takes you some time. You have to go find your smartphone. You have to boot up. It reads one battery. You can scroll from it to the next to the next. But when you're cruising, you want something you can look at a glance and know what the state of your batteries are. So in the lower left here, you can see this Victron monitor that is a round gauge. Xantrex has a similar one. That works very well. The Link and the Link Lite. This is the BMV 712. has a wealth of information that's available. It has a lot of alarms that you can program into it. And that's a feature that, I'd like you guys to take away today that very few people take advantage of. Your battery chargers, your battery monitors have alarms in there. If the BMS is going to shut down battery discharge at 10.5 volts, program your monitor, program your chargers to give you a low voltage or a low battery alarm at 11.5 volts. And so you get an early warning. You can go ahead and start charging, start a generator, whatever, to deal with the situation instead of just the BMS shutting everything down. Use these alarms to help you manage your electrical system. But another good practice is, so let me go back to the first bullet on amp hours, state of charge, amps, and voltage on your monitoring device. You'll want to pay attention to that as you're cruising, because with lithium, the voltage, primarily you should look at amp hours and state of charge. The voltage discharge curve with lithium is so flat that we can't do what we used to do and say, oh, well, I discharged all the way down to 12.3 and now I'm going to start my charging devices. Well, in lithium, you're going to be in the 13s most of the time, not the 12s. And it's going to be most of the time between 13.2 and 13.4 something. So you're having to memorize state of charge versus second and third decimal places on these, on your voltage reading. Much better just to pay attention to amp hours. How many amp hours am I down? I'm down, whatever, 250 amp hours out of a 1200 amp hour bank. I'm in good shape. You can look at state of charge, and the only caution there is that state of charge will work pretty well once it's been calibrated. If the Victron BMV 712, for example, its default settings will not give you good state of charge readings on lithium. You have to set it to proper settings. And then it has to go through a calibration cycle. And over time, once it's done a calibration cycle, it will read pretty well. But then over time, it starts to drift. And it's not a drift in the device itself. It's the way it has to approximate how many amps you used over some finite interval. And it keeps adding all those up. But it's having to approximate that because your amps may cycle up or down within that interval. And so it's picking maybe the average of the start and end point, but who knows, maybe you had a spike or a big dip somewhere between those points. So the thing to take away from this is that, don't hang your head on state of charge and say, oh, it says I'm at 50%. Well, it might be, but if it's been a long time since you've done a full charge all the way up to float, it could be off. And that's how you calibrate these devices. And even in our BMS, that's how you calibrate it as well. It self-calibrates if you charge all the way up to float. So the 90-10 rule. With lithium, what you want to do is try to operate between 10% capacity and 90% capacity. You don't want to sit at dead empty all the time. Now, that dead empty will be a 0% state of charge, but that's not at a point that's damaging the BMS. Stops your discharge at some setting, typically 10.5 volts is a default setting. And you have to get all the way down to about 9.1, 9.2 volts before you're starting to do some damage to a lithium battery or lithium cell. So it's stopping you sooner, but you still don't want to keep operating at that low end. And what happens over time is some of the lithium ions build a little crystalline formation on the anode and don't go back into solution. So it's fine to discharge all the way down to 10%, and then just charge back up. Just don't stay down, at 10% or lower. Go to zero, charge a little bit, then discharge some more, charge a little bit, discharge, so that you're staying below 10%. And the same thing at the other end. You don't want to stay between 100% and 90%. Don't just keep charging everything all the time so you never get below 90%. It's better to let lithium just discharge and charge it up, let it discharge, even if you partially. So I'm not saying you have to discharge all the way to 10%, but if let's say you're at 90% and you discharge to 80% and then charge it up to 90, I mean, that's fine. These batteries will take that all day. It's not a problem. So use it as a convenience, wherever it's convenient, charge, but periodically then every 2 weeks while you're cruising or so, charge it all the way up to full, all the way up to float. And that gets all the equipment recalibrated. You fully exercised all the lithium that's in solution in your battery. You're getting it all used. And so, it's periodically you can go above 90 and periodically you can go below 10. You just don't want to stay in those zones. And that's sort of the frequently discharged. You don't want to frequently discharge to 0% state of charge. In cold conditions, which is freezing, water temperature freezing is a pretty good reference. You don't want the temperature at the battery in the battery bank to be getting below 32 and then try charging at that point. If it's in storage, it's fine. It's not a problem. The issue is charging. And in fact, you can discharge. Let's say, you're in the Salty Dog Rally, you're departing right on the backside of a cold front, and it's bitterly cold. It's freezing. It's 15 degrees. Now, I know you don't want to hear that, but that can happen. And until you get over across the Gulf Stream, and then things become so much milder. It's amazing. But if it's that cold and it's that cold in the cabin, then you don't want to be charging. And what do you do when you're underway? And you basically need to get that cabin warmed up. You turn on some heat, whatever. And so, but what you will find is with Bluetooth, you'll be able to check it, and it may be 0 degrees outside, and you say, oh shoot, the batteries are at 38 degrees, 39, 40 degrees, whatever. So, you do pay attention to it, and just be careful. Now, the BMS, if it's a good BMS, will not allow you. You could try charging, you forget this, and you think the battery should be warm enough, you try charging. The BMS will not allow the batteries to accept charge when the cells are below freezing, below 32. So, Bluetooth is a good tool. It shouldn't be your primary means of monitoring the status, but it can give you a lot of battery by battery specific performance. It gives you tons of data. I mean, ours monitors 52 parameters. You can't pay attention to all of those. Let the BMS pay attention to them, but look at state of charge. Look at the cell performance. Are they pretty well balanced when you're getting up near full charge? And are the temperatures staying down at moderate levels, staying down below 110 degrees Fahrenheit? You'd have to do a lot of really high rate of charge, probably higher than you even have the capability to do, to drive the temperatures up that high or higher. But it's something just to look at and pay attention, because maybe you have some faulty charger behavior as well. So storage, if you're going to leave the boat, you're going to leave it in the islands and fly back to the US, charge the batteries to 70%, and just leave them, remove all the loads. And you got to be, the best thing is just to lift the negative lead off the battery. And then you know that you're not getting any parasitic loads from some monitoring devices or whatever. If possible, if you're going to leave it in storage for more than 6 months, say up to a year, it would be good to have someone go ahead and put some loads on, reconnect the batteries, pull the batteries down a bit, then charge them back up to 70%, disconnect and move on. So it's a good practice. Not absolutely necessary, but some of the lab testing has shown that leaving for long periods and then trying to use normally, then leaving for a long period again on the order of a year, that you do start to lose some of the capacity out of the battery. And you can avoid that by doing this cycling, one cycle in the middle of the year if it's sitting for a year. If it's sitting for 6 months, I think you're fine. So some of the lithium risks, we hear a lot in the news about this lithium fire, that lithium fire, whatever. It's important to recognize that not all lithiums are the same. There are actually 22 different lithium battery chemistries, but very few are used because there are only a small number out of that larger set are used because they're just not very effective in serving as a battery. But there are several that are, and here, I'm listing them here. And so there are several different types. There is a type that's just generically referred to as lithium metal. And it's like this Energizer battery that's to the right. It's the lithium battery, but it's a one-time use. It's disposable. This type 1 is used in security systems. motion sensors and that type of thing, and they'll last in that standby application for 2 years. But it's so generally called lithium metal. It's not a type that's useful for us because we want rechargeable. So there's two primary types of rechargeable. One is lithium cobalt and lithium manganese varieties. All of those are ones that are very high energy density. It's a lot of power in a small package. That's what's in our cell phones. It may have, instead of a liquid, it may be a polymer electrolyte, but it's still the same. They're typically highly combustible. They can self-ignite. That's why there's a lot of cautions about our cell phones and computers. If you see the pack starting to swell a bit, the back of the pack, then it's time to replace. Don't push it. Don't keep charging it. But the hoverboards had those problems. So if you're going to have hoverboards on board your boat, those are the lithium batteries you want to pay attention to and be really, really careful where you put them. Don't let them get thrown around on the boat when you're underway. And the same with computers and cell phones. You don't want them thrown around. Impact can, cause some mechanical damage that creates a short inside. The main reason there's such a problem is that the oxygen that's attached as part of the chemical bond is not very stable. And if disturbed or dropped, overcharged, overheated, the oxygen gets released. And so now you've got a combustible electrolyte, you've got oxygen. All it takes is a little short circuit from disturbance of the battery, and you get an explosion. So just be very, very careful with any of those applications. Small toys that have lithium batteries in them, those are the ones you want to be careful of. Drones, be careful. Store it carefully on board the boat, and take a look at it periodically. Make sure things aren't swelling. Lithium iron phosphate is the other type of rechargeable. It's widely used in boats and RVs, in electric vehicles. It's very stable. It doesn't self-ignite. The oxygen is a very, very strong bond. It's hard to get that oxygen released. It does have a small inventory of combustible electrolytes. So you take a battery like the 105 amp hour modular that's to the right there, that would have about a pint of electrolyte in it total. So it's a small inventory of combustible. And so, most all batteries are subjected to, very rigid testing, dropping from 3 feet so that they maintain their integrity. And the lithium iron phosphate also has excellent deep cycle performance and a long life. And it's just really the perfect match for, what we want to do on our boats. You want to avoid extreme heat and overcharging, and that extreme heat is going to be over the 120, 140 range. And then if it were in some, serious rapid charging or discharging, then you get concerned about getting it too hot. The ABYC letter from the president of ABYC a year ago summarized their tests with lithium iron phosphate. And they said, we tried everything. We saw these alleged scenarios of lithium iron phosphate causing fires on boats. We recreated those, tested them under every condition we could. We overheated them. We drove nails through them. We couldn't create a fire. And so, it's very reassuring. And I think a lot of the insurance companies now are starting to come around a bit and realize that there really are differences in different types of lithium. The other is to compare it to the volume of combustibles that we have aboard the boat, with diesel fuel, gasoline for dinghies, propane for ovens and stoves, lubricating oils. And then the largest one is the resin in our fiberglasses. It is combustible. It's probably the largest volume of fuel that we have on board the boat from a fire standpoint. So sort of in summary, defense in depth approach. I've itemized things here. I'm not going to go back through these again. We'll take some time for Q&As here, but you want to make sure you have quality cells and batteries, reputable company, installed by a qualified electrician. The ABYC standards are critical. If you install it yourself, have someone else who's certified inspect it. You want to make sure you have proper settings in all your charging equipment. Apply best practices, as I outlined earlier. Make sure you program early alarms. So, take all of these into consideration, and it's really a defense in depth approach. There's not one thing that makes it safe. It's all of these things. that you want to do, on board your boat and in using your lithium battery. So with that, here's some contact information. If you ever want to reach me with a question, whether you're using our products or not, glad to help. Committed to the Salty Dogs and helping them. And so we are sponsors of the Salty Dog, which gives us the Salty Dog Sailing Association, which gives us the opportunity to share this info with you in a webinar like this. But, we support you beyond that on any of your needs. So thank you. And I look forward to some questions.
Okay, Hank, it's George Day back here. That was wonderful. It was very absorbing. I mean, I've spent a lot of time looking at this as myself, but I haven't seen anything quite so lucid as what you just delivered. So well done. Thank you. I actually sailed with Bob Osborne last fall on Pandora and with the new system. And I have to say that we got into the horse latitudes. It got pretty hot, and we were able to turn on the air conditioning on the boat just from the lithium ion battery bank. So we were sleeping cool in hot conditions just off the battery bank. So was pretty. I've never experienced that before. So anyways, we have some questions here. We have from Babs Carver. Can you mention the device name to control output and distribution? I'm not quite sure what she means by that.
Yeah, so there was a picture on the lower right screen of the little green.
Yes. So this is a great little device that can be used to interface your alternator with the house bank. It's referred to as a BIM, Battery Isolation Manager. That particular model is a BIM LI for lithium 225, and it's by a company called Scientific Circuits. It's very widely used. A lot of folks carry it. We don't list it on our website, but we carry it. We have an inventory here that we've, as our dealers need them, we've shipped to them, but we can make that available as well.
And we had a second question about the fire extinguisher. It took us a lot of searching to find something that was less than $1,000, like for lithium. It was quite extraordinary.
Yeah, it is. It can be a challenge. And so part of the problem when they do that rating is those are for some different configurations than what we have. And they can be the lithium metal batteries, and they're inside some smoke detector or whatever. And, they want to try to flood the whole outside. So I don't know that I can give you any further recommendation than, look for that. Generally, if you have a water supply, water can actually do a fair amount in removing a lot of the heat. The others on, the problem is some of the others with foam and that sort of thing. I don't think are great around our boats. They're highly acidic, and so it's going to cause other problems with electrical connections over the long term.
Hank, I just had a question. I mean, on my boats, I have integrated charging from solar, wind, and the alternator, and we just go straight to the batteries. I mean, we run the wind and solar through the regulators, but with lithium, I just wanted to be a little clearer on how you manage that sort of integration between wind, solar, and the alternator.
Yeah, I think what you want to try to do on your large charging sources is to feed them direct to the house battery bank, so that it's making that major contribution to those large loads. On solar, the solar controllers, the MPPT controllers that you have, most all of those are programmable, so you can set them to the desired settings. The manufacturer of the lithium battery will identify certain key parameters. They'll say, I want absorption at 14.2 or whatever, float at 13.5. I want rebulk at maybe 13.2. And I want you to deactivate equalization. So you can go into your MPPT and change those settings, just like you can in most chargers, battery chargers. The wind generator tends to be the more difficult. There are some controllers out there, regulators that can accommodate lithium. or that allow you to sort of emulate a three-stage charging. You can adjust the settings for that, but most do not. Most are, but there are a few of them, like the D400 now, the manufacturer of that has a controller. The other one was like Wind Kinetics, I think is the name, has one that has lithium settings on it. But a number of folks that have them, they look at that and they say, wow, that's another $500 to change that. And my wind generator regulator is working. So if you keep a battery as an AGM, like a start battery or a bow thruster battery, route the wind generator to those with the existing controller. And then you use a DC to DC charger to harvest the excess energy that's going to that battery to send it back to the house bank. And that DC to DC charger, like Victrons, are ones that you can then specify the specific, these values that I just gave you, 14.2 on absorption. So you tell it that that's what I want. You can set the threshold as to when you want it to sense that charging is taking place. Because that's an AGM battery, you might set it at something like, maybe a 13.2 or something like that. So when the battery is brought up to that level, that AGM battery is brought to that level, the DC to DC charger switches on and then starts taking charge. So it won't be taking charge when you're charging at the lower level until that battery is getting up to its higher level, but then it starts taking it off of there. And if there's excess energy that the wind generator keeps producing, then it takes that and sends that over to the house battery, where otherwise, without doing that, the wind generator would just go into its off position or standby position.
Correct. I just have one other point, Hank, that might be worth making, is that lithium installing a lithium battery bank on a sailboat is considerably more expensive than putting an AGM battery bank on. Obviously, there's many more benefits, but can you give an idea of what the curve is in terms of the cost of lithium versus the cost of 3 generations of AGMs?
Yeah, sort of off the top of my head, I think it's going to be a little difficult to do that, but
Yeah, sure.
So we had a client that was looking at replacing their golf cart 6-volt batteries with the Lifeline AGMs, and the cost of that was going to be in the range of $2,200, and it was only $600 more to put in 2 of our 210 amp hour and have 30% more usable amp hours. So it's not, these days the cost for that lithium is not, hugely different. It is more expensive, but not substantially so. You do want to manage that project in a way that it doesn't drive the cost up a lot. I think a lot of people will get in and say, well, I want to add these other things as well. I want to go ahead and make it twice the amp hours I had before. And they don't realize that, well, then that has a ripple effect of having to upsize cables. It's more labor hours here and there. You maybe need to add another battery charger to be able to charge that, amount of capacity. And so it's not exactly an apples and oranges. You're getting a larger battery bank, more usable hours, even though it is, more expensive.
And just one last question. I'm a do-it-yourselfer sort of guy. I mean, I've repowered my own boats with batteries and recabled and all that sort of stuff. Do you think that someone with who's knows enough to be dangerous should attempt a self refit, or should they work with an expert to do the job?
Well, I think there are quite a few folks that are very capable. They've worked on boats for decades and they know the basics. You can get some guidance from a battery manufacturer, the lithium battery manufacturer, to help you. But I would just strongly encourage someone doing that to then have a AVYC technician come and look at the work and double check it, double check your settings, double check your connections, your crimp fittings, all of that to make sure it's sound. It's just the right thing to do. There have been a number of boat fires over this past year that I received reports on. And some of those had lithium batteries, and every one of them, it was loose or corroded connections, ended up being the source of the fire. So it's, you can't emphasize that enough. Get someone else, another pair of eyes, someone who knows what they're looking at, to go look at this stuff, even if you're going to do it yourself and you feel like you're capable.
Okay, good. I just have one last question from Peter Sorlin. How often should one check the firmware for BMS and battery monitors is up to date? How to update while cruising?
Yeah, I mean, it's a good question. I think what we try to do is keep that, and part of it is my background working in the nuclear field. We try to keep that firmware very simple, and so you're not up against a lot of updates, and so you don't need to do it. And so most manufacturers are trying to do that at a very limited basis. It'll be, some folks like, Victron, Mastervolt, that have software and firmware that is a little more complex and is then susceptible to needing updates. I mean, ours is keeping it very, very simple. So there's not a lot of communication data going back and forth to other equipment. It's self-sustaining. So it's going to be, more like a 5-year window before you need to think about, is there some update that's important on something like ours. With Victron, they try to do an annual update, and most all of that happens when you use their Bluetooth app, and then you connect up to devices, whether it's battery chargers, the MPPTs, things of that nature. Those are ones that get updated automatically. What's interesting is your Victron Connect app. When you update it, it updates all the firmware apps in its memory. And so when you then go connect to your devices, it updates them. And so, it's a very slick approach. And so it makes it pretty easy to do those updates. Mastervolt is somewhat similar. You do it through their Master Adjust software. And then once you open the Master Adjust, you need to have access to internet on your computer. And it then goes and checks the firmware on all those devices, all the Mastervolt equipment. On the BMSs, which was really the question, you're going to find that that's so, I say simple, it covers lots of parameters. It's just comparing it to the set points. And if the manufacturer then has decided that they think there's a different set point needed, you should be able to do that just through the Bluetooth app. There would be an email, and you go in through the Bluetooth app and adjust the settings.
Okay,
So-
one last question from Babs, who's been our most avid questioner. She
Okay.
said, you mentioned you worked in the Caribbean. Do you still work there? And if so, where? If not, where do you
Yeah.
recommend any
Okay.
expertise in that area? We already have lithium batteries.
Yep. Wayne, and I forget Wayne's last name. I might be able to pull it up here, in Antigua. And he's at Jolly Harbor at that boatyard, is excellent. He's installed our batteries. And so he's very good. The other is Horizon Yachts down in Grenada. They've got excellent people down there. We every other month we're shipping them a supply of our batteries. And so they're doing a number of installs, and some that are pretty complex right now, so pretty interesting. So I think they're quite knowledgeable. So those are two I would give you. If you are stuck somewhere, get in touch with us, and we may be able to find someone that's close to where you are.
Cool. Okay, just want to end. We have two just little kudos from Perfect View. Perfect View has Blue Heron installed batteries installed last spring. Great technology and great support. And then from Tim Metcalf, who is a Salty Dog support team leader, I installed a Blue Heron 315 amp hour this year. I love it. So there we go. Thank you, Hank, very much. Very great presentation. I learned a lot, and I think everybody did. And those who signed up stayed for the entire presentation. So thank you all for joining us.
And I guess as with all the webinars, Tatcha will be, I guess we'll want to turn off the recording when you're ready, George, so that gets saved. And I think Tatcha sends a link to everyone who registered. So, you'll have access to all the slides I showed and the comments.
The recording is just being stopped.
Okay.